Okay. Let's see. Are we on 8.3 or 8.4? Okay, number 12. A squared plus 20a plus 100. Number 14. H squared plus 14h plus 49. 16, 64 minus 16m plus m squared. 18, 4b squared plus 12b plus 9. 20, 64h squared minus 64hn plus 16n squared. 22, u squared minus 9. 24, 4 minus x squared. 26, 4q squared minus 25 r squared. 28, 25, y squared plus 70y plus 49. 30, 100 x squared minus 4. 32, a squared plus 8ab plus 16b squared. 34, 4c squared minus 36cd plus 81d squared. 36, 36y squared minus 169. 38, 25 x to the fourth minus 10x squared y squared plus y to the fourth. 40, 9/16 k squared plus 12k plus 64. 42, 49 z to the fourth minus 25 y to the fourth. 44. Okay. What 14 again? H squared plus 14h plus 49. Good job. Reading's hard. All right. What other questions do we have on this lesson? 40's fine. Okay. What should we do? Sure. Mm-hmm. No. It's not even one equation. There's no equals. Okay, now what? Sounds totally fine. What's 3/4 k times 3/4 k? 9/16 k squared. Now what? Times 8. What's 3/4 k times 8? Mm. What's 8 times 3/4 k? 6k. What's 8 times 8? True enough. Now what? Combine like terms. what other questions do we have?
38.
Okay. Okay. Now what? Okay. I did show y'all a shortcut on how to do these, but that's fine.
That's what it was about. It doesn't mean I ever missed or something, but we do one with a shortcut so they could write.
Sure. Why not? Okay, now what?
5x squared times 5x squared.
In other words, we're going to distribute, right? What's 5x squared times 5x squared? What's 5x squared times negative y squared? What's negative y squared times 5x squared? What's negative y squared times negative y squared? True enough. 25 times 4. Why are you saying 25 times 4? That's crazy, bro. An internet hooligan. Now what? True enough. Right here and right there. All right, what other questions do we have?
Can we do 32 with a shortcut?
Can we do 32 with a shortcut? Yes, we can. I wish we didn't have Grace tomorrow, so we could just be on spring break. That would be nice. It's a co-op.
It's a cool co-op. We don't want him on.
It is a good co-op, but I wish we weren't having it tomorrow. Because then we could just be on spring break. That would be nice. What is the binomial squared theorem? Those of you who did the shortcut.
Is that the first 32?
It's good enough.
Okay, well then. The binomial square theorem, you said?
Yeah.
Yeah, that's right.
Good. On this problem, what's A?
3 cubed,
What's B?
5r. Or negative 5r.
What's 3 squared? What's q squared? What's 3q times negative 5r times 2? Negative 30. What's negative 5r squared? You're a liar. 25. Positive 25. 25r squared. Easy peasy. You don't have to use the binomial square theorem, and especially in Algebra 1, if it's like, okay, I'm confused on that, I can do it the other way, just do it the other way, it's fine. Now, you eventually will want to get better at it, because then you're going to do like ugly stuff and a whole heap of them. You're going to pre-cal problem with a whole bunch of other stuff. So eventually you'll want to be able to do it with a shortcut, but that doesn't have to be this year at all. Just as long as you don't make the dumb mistake of just putting these two down. What other questions from this lesson do we have? Okay. Maybe. That's crazy.
The hard part is I do believe you for half a second.
Crazy.
Yeah. We did 33 actually.
What was that called?
Gaslighting.
Yeah, gaslighting.
Gaslighting doesn't exist. I don't know.
Yes, it does.
Where did I set my marker? What? Where is my marker? Probably. I wouldn't put it past you.
What
What'd I do? I didn't do it.
The black marker?
Well, you're like barely paying attention to anything today. Of course you didn't do it. You're like in distraction mode today. I thought about that. Oh, no, that's my phone. What did I do with it?
It disappeared.
It did.
It's in the woods somewhere.
It'd be funny if I put it in my jacket pocket and then took my jacket off. That would be really silly. Oh, that's exactly what I did. Okay. All right. Let's look at some advanced stuffs. Move forward with our life. So, what did you say? We're doing 30. Why do we need to do 34? Just check your work. You probably made a small mistake. Check your work, girlfriend. See if you can find it. Message deleted. Message deleted. On board. Oh, welcome on board. Hey there, Katie. She probably doesn't really have a ride. Her mother has left her.
What?
Temporarily. Temporarily. Did you find your mistake? Why not? 4c squared minus 36cd plus 81d squared. Did you accidentally just square the first one and square the last one? Did you make a silly mistake? Probably. Clearly not.
Yes, I did use the shortcut. I would like to move on now.
Okay. Let's talk about factoring. Okay, so we have talked about foiling. We're talking about using the distributive property, which is great. It's grand, it's glorious, it's useful. But what if we want to go the other way around? What if we want to take something that's split up into a bunch of sums, the product of sums, and turn it into, sums of products and turn it into products of sums. So we've got all these terms, and we want to put it back into parentheses, which is often way more useful. So there are a few different ways to go the other way around. The first and most useful thing to keep, because you pretty much always will look for one of these. If the instructions say to factor, almost always, your first step is to look for a greatest common factor. Okay. So, and we could shortcut the thought of what a greatest common factor is by saying something like, what does every term have?
Wait, I almost wrote what is the philosophy?
Wait, what? Wait, why? Wait, who?
That used to be my favorite song.
I believe that. This totally checks out. This is totally on brand. Okay, so for example, the instructions said factor. And you had something like 8c squared x minus 32y c x to the fifth. We'll look for a GCF first. We want to see, does anything go into both of those terms? So we look at the numbers first. Does any number go into 8 and 32? 8 does. So we're going to start writing down our GCFs. I'm going to write down an 8. So they have any letters that are in common between them? C. They both have one C, and they both have one X. This one has 2 C's, and this one has 5 X's, but they have at least one of each. So now that we've written out the GCF, our next phase is to write a parentheses. So remember, we're taking terms and turning it into multiplication. We're taking sums of products and turning it into products of sums. Is the excessive distractions necessary? And to figure out what's left, that's clearly a no answer, girlfriend. Clearly a no answer. Put your pencil back to your paper. Anyway. To figure out what is left when we pull this out, we are dividing. So we're dividing 8c squared x by 8cx. So what's 8 divided by 8? 1. What's c squared divided by c? C squared divided by c. What is that? Definitely not c squared. Just c. 2 minus 1 is 1, right? If there's 2 up there and 1 down there, we take 1 out, there's 1 left. Either way you look at it, there's a c left. X divided by x is what? 1. Anything divided by itself is 1. So all that's left in the first term is just a c. Minus, what is 32 divided by 8? 4. What is y divided by nothing? Y. What's c divided by c? What's x to the fifth divided by x? X to the fourth. Congratulations, you've just done your first factoring. Why are you saying Okay. When?
Yesterday.
Oh, you're trying to get ahead in your homework?
Yeah, because I keep getting behind.
Gotcha. So you're trying to stay ahead? Probably a good idea. Okay. Let's do another example. This one is a little bit different. Okay. So we've got 4 terms, right? Nice. Right. So we're trying to completely turn this into a product of sum. So we want everything in parentheses or multiplied times parentheses. Is there a GCF in all 4 terms? One doesn't count. Everything's divisible by 1. Definitely not. Right? They don't all have a B. They don't all have a C. 2 doesn't go into everything. 3 doesn't go into everything. 10 doesn't. It doesn't work. 5 doesn't go into everything. They don't have common factors. So this is a different kind of problem. This one, really, we're going to do GCF twice. But we have 4 terms, and it says factor. Then we're going to do factoring by grouping. So our first step to factoring by grouping is to group it. And to figure out how the groups need to work, we need to look at our signs. Okay? So on the first one, we've got plus minus. On the next one, we've got minus plus. This one has got even one more thing that's going a little bit crazy. What do you notice if you look at all 4 of those things? 2 of them have something in common that none of the rest of them do. 2 of them have a B, that's true. What's one other thing that they have in common? Not the negative signs, that's not what we're looking at. 2 of them have a B, what else do 2 of them have? C. There's 2 of them that have C. You did, but then everybody else was like B. And so I paused on the B because multiple people said it. Yes, you did.
Well, also has multiple B's. Why would it be, I didn't see the B's. Wait, why would it be C instead of B?
Would you stop and let me teach, please? Okay. Let's take and flip these around, and then let's see if we can see something that looks reasonable. If we can see a C. So we're going to try to get this to where the front half kind of sort of matches the back half, which we kind of did by just switching those 2 things. Look at the front half and compare it to the back half and tell me what you see. B's are only in the front half. This one doesn't have any B's. True enough. What else do you see? So 3 goes into this one, true enough, and it's got a C there. What else do you see?
Is it that the 2 factors be in?
Everything we've said is that, but like, what are you adding to the thing? Like everything that's been said so far is exactly correct observations. And what have you seen that we haven't mentioned?
B and C are next to each other instead of being separated by the 10.
True enough. So they're in the same order, right? True enough. There's kind of one more thought in there, thought bubble in there.
Is it plus minus plus minus?
It is. The signs match. Also, 2 goes into both of these. So we've ordered it probably happy because it's kind of all meshing, front half, back half. Now let's do something. We're going to split this up into 2 groups, hence the factoring by grouping. Whoa. If we look at the first half, the left side, what is the GCF between just those 2? What's in common between those 2? No.
Wait, in between what?
These 2. The first 2, not the last 2. The first is this way, this is left. They do have a B. And that's all that's in common on the first chunk, right? Okay. If I pull a b out of the first chunk, if I pull a b out of this first term, what's left? Oh, you forgot something important. 3c. True enough. If I pull a b out of this one, what's left? Negative 2. If I look at the second group, what's the GCF over there? Now it's a 5. And pull out a plus 5. When I pull a 5 out of the first one, what's left? 3c. 15 divided by 5, not like some sort of weird subtraction thing. 3c. When I pull a 5 out of the negative 10, what's left? Negative 2. Not subtraction, division. Okay, what do you see now?
They look the same.
They look the same. They're the same. So now we have 2 terms that have something in common. Yeah, if you distribute, you're going to go right back to this way. So you have something in common between this term and that term. What's in common between these two? 3c minus 2. So we can pull out a 3c minus 2. When I pull a 3c minus 2 out of this first one, what's left? B. When I pull a 3c minus 2 out of that one, what's left? 5. So just to prove that this works, and this is the same as this, let's do what we've been doing. Get a little more practice there. What are you saying?
I said, how about you just take out the B and the B's on top, and then just take the No, that's not right. Go on.
This isn't Hogwarts. We don't do magic here. Only math. Okay, so if we're going to FOIL this, let's do it just like what we've been doing. What's 3c times b? 3bc. What's 3c times 5? Because 3 times 5 is 15, and then say the word c after. What's negative 2 times b? Negative 2 times 5 is? Same. Cool beans? Let's do another one of those. Why the depression? The math is mathing, bro. Whip it real good. What? Yeah, a little bit. Poquito. Let's see here. Let's do this one. Okay, what could we do? What's not possible?
Grouping.
I actually do have a common factor, but
Is that a 9 or a cube?
that's a 9.
Well, how's it
You're not wrong. The 9s and the Q's sometimes do kind of look similar. You can tell the difference with my stuff, especially by looking where the baseline is. They do have a 2 in common. We could try going ahead and taking a 2 out first and see what happens from there. Okay, so what's 48 TU divided by 2? TU, right? What is negative 90 T divided by 2? Good try. Negative 45.
T.
What's 32U divided by 2? 16. U.
Gosh, I'm sorry.
What's negative 60 divided by 2? What? Okay, now what? That's going to put it back. Definitely not distribute. That's going backwards. I think we should try grouping. I think that's a great idea. Yeah. Okay. Now what? What's in common between 24 TU and negative 45 T? T. That's not all that's in common. Look again. Well, did you write it down? No, because 45 isn't divisible by 2. Well, 1 doesn't count, but thanks for playing.
3.
3 goes into both. 3 does. When we take a 3T out of the first one, what's left?
8.
8U. When we take a 3T out of the second one, what's left?
Negative 15T.
Negative 15T. Except that's a lie. Negative 15. We took the T out. That's crazy. All right, what's in common on the second one?
3.
Definitely not. 2. Numbers, I think. It's hard to tell sometimes.
Well, and we're talking about letters.
If we take a 2 out of that first one there, what's left? 8U. It matches. Maybe we're doing something right. If it doesn't match, you done did something wrong. If we take a 2 out of the next one, what's left? Negative 15. That's a good way to accidentally make a mistake because you're like, I know it should match. I'm just going to write stuff and not realize that you made a mistake. Okay, what now? You look sleepy.
I am.
Okay,
How'd you do that?
you tell me.
Working on it. Okay. There's like a way to remember how to do that.
Yeah, factor.
Because the ones that match go in the front, and then the stuff that's outside of the ones that match, the 3T and the 2 go in the other parentheses.
because you're pulling an 8u minus 15 out
Okay.
of these terms.
So then having
You're very distracted with that cord. You should put the cord away, possibly move seats.
and
Yeah, but what if you do it?
it goes into the other part. So with the 8u u minus 15 two times and then parentheses 8u times 8u minus 15. Oh, sorry. Because there was two of them, is that why there's a two times or is it just
The
there?
2 is there because we pull the 2 out right here.
Okay.
If you were to put it back, you would have to distribute the 2 back in at some point. Yeah. But that 2 came from there.
But the bottom two, it came from.
He just like dropping down. Boom, 2, 2, 2. He just following. He's just like little brother, just hanging on.
Can you just add it back in? Oh, back in.
That's a great idea, Lucy. Do you really want to do one, or you just want to brag a little that you're kind of getting it?
No. Make sure
Okay.
He has to brag about it.
Jay said that.
Why did he?
They don't believe that he did.
You didn't do that.
You better stop being
You're bullying Kyle.
and me.
That's not bullying anyone, Jace.
That's not defined as bullying. There's no power dynamic there. Bullying requires a power difference. Otherwise, it could be pestering, it could be being ugly, it could be doing like a lot of different things, but it's not bullying. People like to call things bullying that aren't bullying. That doesn't mean you're not being a jerk or something. I mean, that's only possible. But that doesn't make it bullying. Ready, go. Lock in, chat. Oh my gosh, you're like so. I wouldn't say you're sheltered. That's the wrong word. Isolated.
Let's chat though.
It's okay, Jace. Don't worry about it. This time we're not gaslighting you, but it's not important. The math is important right now.
I know, that's what I think right now. You're gaslighting me.
Focus. Probably because he's probably doing it because he knows it annoys me. No, I wouldn't do that.
I think that'll be the first to say I'm a little bit confused.
What you talking about, girlfriend? Where'd you get lost?
Second step.
Okay. Tell me how I did it.
That's what you said.
No, you're not. Not as much as you think. You got this. Fight for it. Where'd the 5B come from?
Top one.
True. What part?
Beginning. They have it in common.
Which ones have it in common?
The other one.
Girl, there is this one, this one, this one, and this one. Which ones have 5B in it?
The second one.
The first two, right? So that's where the 5B came from. Where did the first R minus 5 come from?
When you divided 25.
No, not the 25. Well, the R part came from here, right? This divided by 5b is R. This divided by 5b is this, right? Where the 2 come from?
The
Second set. Got 2 in common. And then we divided it out. Mm-hmm. You got this. Okay. Let's do another thing. Let's factor trinomials, shall we? It means it's a polynomial with 3 terms in it. Trinomials. That's what we've been learning about this whole time. Polynomials. We learned that in like lesson 1. Things like this.
Oh, okay.
Okay.
Closing your eyes. I wasn't trying to do it well.
I didn't have that. Okay. Factoring trinomials is not hard, but it's going to be a little hard at first. A little bit. Eventually, you're going to be able to do them like that. You're going to be able to just look at it and be like, okay, here's the answer. At first, the method I teach is officially called guess and check. You're liable to guess and then check a few times. I also call it the smiley face method. You're going to see why in a minute. Part of it does. Okay. So, let's start with an example. N squared minus 2n minus 35. I will note that in the instructions in the homework set that's coming up for this, it says factor each polynomial, confirm with a graphing calculator. Don't do that part because you probably don't even have one of those. And even if you do, I'm not going to teach you how to do it because that's a waste right now. Okay, so the way to factor a trinomial. How do I know that's a trinomial? I'm asking like questions and y'all are talking, which is clearly distracted. Because there are 3 terms, he's a trinomial. In order to factor a trinomial, step 1 is look for a GCF. Is there a GCF? Yes. Welcome back. No, there's not a GCF. Nothing goes into all 3. So that's no big deal. Next step is easy. If you cannot do this next step, I have no hope for you. Like none. Like none at all. Because step 1 is 2 sets of parentheses. Okay?
No, I'm sorry.
What?
How do you do parentheses?
Okay. Now, this one is that there are kind of 2 levels to factoring trinomials. One is where this A term right here is a 1. These are easier. And so I'm going to say some extra words when we're doing this one that seem useless for now, but then when A is not 1, they're less useless later. So trust the process. Answer the questions I'm actually asking. Inside the parentheses, there are 2 slots. There's the front slots and the last slots, the back slots. In the first slots, we need 2 things that multiply to get the first term. So what times what gives us n squared? N times n. Easy peasy. In the second slot, I need 2 things that multiply to get 35. Especially at the beginning, that might be a useful idea to kind of jot down what those are. So what are the factors of 35? Don't worry, I'll get the hard one for you first. 35 and 1. What are the other factors of 35? 5 and 7. True enough. Now here's the guess part of the guess and check. Pick one of those. 35 and 1 sounds great. Let's do it. Now here's the smiley face part of the smiley face method. We're going to draw his nose and his mouth. 35 times 1n is what? 35 in. 1n times 1 is what? N. Now, we are trying to either add or subtract these numbers to get this one. So can you, in any way, shape, or form, add 35 and 1 to get a negative 2? No, you cannot. We picked wrong. Good job, team. So now that we've guessed that, let's guess our other option. 5 and 7. 5 times 1 is 5. 1 times 7 is 7. Can we add or subtract those to get a negative 2? Yes. What do the signs need to be? Both of them? Negative 5 minus 7 is negative 2, is what you're telling me. Plus 5 minus 7. We're going to follow our nose and put a plus, and our mouth and put a minus. This factors into that. Okay, let's do another one of those. Okay, what do we need to do for this one? See if there's a GCF. Is there a GCF?
Yes.
Yes. What can we pull out? A 2. When I pull a 2 out of the first term, what's left? D squared. When I pull a 2 out of the second term, what's left? 18D. When I pull a 2 out of the last term, what's left? 56. Okay, now what? Definitely not. 2 sets of parentheses. The little brother 2 is just going to follow the big brother down the way. What's going to go in the first slot? D times D is D squared. What are our options for 56? What are the possible ways of multiplying at 56? 4 and 4 times 1 is 56? What? 4 times what is 56?
14.
Okay. What are our other options? 56 and 1, 8 and 7.
Let's just do the 28 and 2.
Let's just do the 28 and 2. Great, let's do it. 28 times 1 is 28. 1 times 2 is 2. Can we add or subtract those to get 18? See or no? Not so much. Let's try a different set. 4 and 14, he says. 4 times 1 is 4. 1 times 14 is 14. Can we add or subtract those to get 18? Yes. What do the signs need to be? Positive, positive. Follow our nose. Follow our mouth. And we did it. Let's do uno más, but with a twist. What did he say? Because. Twist again, like we did last summer.
You broke. It's too expensive. You broke your phone like 80 times. I know. I never threw it.
You should watch it. You do it instantly. Mine broke right like this big.
We're going to solve this for y.
Okay.
This is a quadratic. I know it's quadratic because it's got a square in it. Squared is the degree. It's the biggest one, right? So if we're lucky, if we're really lucky, which we are, we can solve this with factoring. So the first thing we're going to do is we're going to factor this left side. This guy's just going to hang out. So blam, blam, blam equals 0. What's going to go in the first slot? Y and y. Because y times y is y squared. What are the options for the last slot? 10 times 2. What do we want to try? 2 and 10. 2 times 1 is 2. 1 times 10 is 10. We're trying to add or subtract to get 1. Can we do it?
No.
Definitely not.
We're trying to get 1. Why are we trying to get 1? Because one right there?
Let's do 5.
Why is that one specifically one in the middle?
Yes.
Okay. We're trying to solve for y. Why?
Can we add or subtract those? What do the signs need to be? Follow our nose, follow our mouth, and it's factored and equal to 0, which is important in order to solve for the y. So once an equation is factored and equal to 0, we have the ability to just set each factor equal to 0. So y plus 5 equals 0. And y minus 4 equals 0. That's just this equals 0 and this equals 0, right? How do we solve this little baby guy? Minus 5. Easy peasy. So y equals negative 5. How do we solve this little guy? Plus 4. So y equals 4. Y can equal negative 5 or 4. Okay, kids, y'all should go have a wonderful spring break. Well, either you do spring break do math over spring break, or you do it in the normal before and after. You have the same amount of time, even if you take out the spring break. That's whatever. I don't care where you do it, when you do it, as long as you get it done before Tuesday. Actually, by Monday.